Low voltage disconnect. I am from Cebu, and on this video I will try to explain what is low voltage disconnect or LVD and its purpose, and why do we need the relay to pair with our LVD. So this video is intended for my wife, my children, for them to support and troubleshoot my DIY solar. So here is my setup, my DIY solar, and I want them to understand what's the purpose of LVD and relay. So basically, relay has I think one, two, three, four, five, six major parts that you need to understand. Its input, its output, the light indicator if the load is coming out, the voltage reader or reading, and configuration buttons. So there are two configuration buttons that you need to understand. So first is the input. There's an indicator, plus and minus for the positive and negative, and VIN or voltage input. So basically, your battery is directly connected to this input section. So say for example, you have 12 volts or 24 volts. In my end, I have 24 volts. I don't know if it's compatible with 48. I haven't tried, but for 12 and 24, it's compatible. So you just need to directly connect your batteries to the input, and uh, it could read what is the current voltage of your batteries, and it will output here in the V out. So there's also an indicator for positive and negative, positive, and it will output the load from your batteries. So I will explain later what is the purpose of relay. Why are we not directly connecting the load on this output for the LVD? So, but first, we'll focus on the LVD. So here it's reading our batteries at 26 volts. And if you press this button on the left twice, you will see another reading voltage, which is the disconnect voltage. So our batteries is 26. And if I will double press this one, it means that whenever your battery is at 24.6, it will be disconnected. So why is it important? It's because our batteries has, it's called depth depth of discharge or DOD. So there are batteries that needs to be uh, disconnected whenever at certain point of percentage or voltage. So say for example, this battery needs to be disconnected with a load at 50%, and this battery needs to be disconnected at 20%. So there are different types of batteries that you need to consider, but I'll be focusing on the LVD. So in my end, the voltage is 26 and the disconnection is 24.6. So say for example, just for the sake of testing, I'll show you that if I want to disconnect at 26.1, I'll double press this one and increase the settings. You could decrease it on the other button. So 24.6, 25, 25.789. See? So if I want to be disconnected at 26.1, so this is for the test only, my batteries will be disconnected to the load. So it turned off the light indicator here, meaning there's no more voltage going out from your battery based on the LVD. So if I want to, I'll set it again to 25.5. So it reconnects the load. Okay. So as you can see, there's another button here. So the purpose of this one is the reconnect settings. So say for example, I want to disconnect my batteries at 20. Let's disconnect it first. 26.1. So let's set it by 25.7. So it disconnects at 25.7, and say for example you want to reconnect it when it has been charged around 26. So 25.7. So 25.7, 25.8, 25.9, 26. So you only need zero point 0.3 volts to reconnect your LVD. So that's the use of this button. If you double press it, so you will see a point something, and my disconnect is 25.7. So say for example, currently I have zero point 0.6 reconnect. I want to reconnect it whenever it increases its capacity around zero point 0.3 voltage. See? So it reconnects at zero point 0.3 since currently my disconnect is 25.7 and it's already around 26. So that's the purpose of the reconnect button. The disconnect is the specific voltage you want to disconnect, and the reconnect is whenever the capacity already increased and it has been charged already. You can say, for example, if it's already 26, then you can reconnect your batteries from the load. And the other stuff here are just the another technical parts that you don't need to uh, configure. Just leave it as is. So why do we need relay if you already understand the LVD? You're thinking, why are we not connecting directly the load from our LVD? So LVD is quite small. It's just an inch, and the wires are also small. So if you directly connect your inverter or big loads on the LVD, most probably it will burn your LVD, and it it only allows a smaller amperes. So that's why you need your relay. In my end, my relay is 100 amperes. So meaning it can cope up with 100 amperes load. And say for example, my TV, ref, and other appliances I want to connect, then I need a relay in pair with LVD. So this is the input of the relay where your LVD has the output. So you need to connect it with the relay. And these two bigger bolts here is somehow the switch for the relay. So if there is a load going in to the relay, this one or these two are being connected. So I'll show you a simple diagram that I had drawn. So here, this is your relay. This is where I show you. This is where I show you the inputs going to the relay, smaller one, and then the bigger one. Two nuts are where your line will be cut off or connected. So this is a batteries. This is your battery. So for example, this is your battery, and positive, negative. This is your LVD that we explained earlier. So your negative going to the negative input, and your positive going to the positive input, and your output from your LVD going to your relay. Actually, relay doesn't have polarity for its input, but for the sake of the diagram, you can see it here, there, positive, negative. And as you can see, the battery here will be connected to your relay. So that's why it has a bigger wire here in your uh, relay. And going on the first bolt and going to the next one to the inverter. So whenever it's being powered up, this relay will connect this line going to the inverter. And if your LBD turns off, most probably the relay will also cut the connection between these two both. So basically it's your switch on and off to your line from your batteries going to the inverter or to your load. But your negative one is just directly going to your load or your inverter. So overall, whenever your LVD detects that your battery has still have the good capacity, then it will turn on and put the load in the relay and connects this line, and your load or inverter should be connected directly to the battery. And if your battery goes down or will be low bat, then it will shut off the LVD. The LVD will shut off or turn off, and there's no more power on the relay. Then this will be disconnected, so the load and the inverter will also be turned off. So this is my actual setup. This is my LVD. As you can see here, this is my negative from my batteries, and this is my positive going to my inverter. So this is a bigger wire going here, bigger wire for my batteries. And this is my LVD input. So whenever there's a power going here, this will be connected going to my inverter. So hopefully this video helps you as a DIYer for solar, and especially to your family members, your wife, your children that will troubleshoot your DIY solar and you're not around and you won't be able to help them. Hopefully this video will help explaining some basics about solar.